Python Interview Question Series. Part 2, Intermediate Python, Questions 11 to 20. For students, freshers, and Python developers. Intermediate to professional level concepts. Let's begin. Part 2, Intermediate Python, Questions 11 to 20. 10 Intermediate Python Interview Questions. Focus on argument passing, comprehensions, exceptions, and copy modes. Clear structured explanations for each topic. Let us cover question 11, explain function arguments. When you call a function in Python, you can pass data to it in different ways. The first way is positional arguments. These are passed based on their position in the function call. If your function expects name first and then message, you must pass name first. Order matters here. The second way is keyword arguments. Here you specify the parameter name directly when calling the function, so order does not matter. The third way is default arguments. These are fallback values set in the function definition itself. If the caller does not provide that argument, the function uses the default. Look at the code on screen. We define greet with a default message of hello. Calling it with just Alice uses the default and produces hello Alice. Calling it with Bob and specifying message as hi uses keyword syntax and produces hi Bob. Question 12. What are *args and *kwargs? These two special symbols allow functions to accept a variable number of arguments. *args collects any extra positional arguments you pass and packs them neatly into a tuple inside the function. Think of it as a flexible basket that catches extra positional inputs. *kwargs collects any extra keyword arguments and packs them into a dictionary. Think of it as a labeled bag for extra named inputs. Look at the code on screen. We define a function show with both. When we call show with 1, 2, and val equals 3, *args becomes the tuple 1 and 2, and kwargs becomes a dictionary with key val and value 3. This pattern is used extensively when writing decorator wrappers and flexible API functions in professional Python code. Question 13. What are lambda functions? A lambda function is a small anonymous function that you can write in a single line. I like to call them throwaway functions, because you use them for a quick task and move on. They use the lambda keyword, accept parameters, and automatically return the result of a single expression without needing a return keyword. Look at the code on screen. We write square equals lambda x colon x times x. This creates a function that squares any number. On the next line, we use a lambda as the sorting key for a list of tuples, sorting pairs by their second element alphabetically. Lambdas are perfect for short, temporary callback logic like sorting, filtering, or mapping, where writing a full function definition would be unnecessary overhead. Question 14. What is list comprehension? List comprehension is Python's elegant way of creating new lists in a single clean and very fast line of code. The syntax is, opening square bracket, then the expression you want, then for item in your iterable, then optionally an if condition, then closing square bracket. Think of it as a compact for loop that builds a list simultaneously. Look at the code on screen. We filter even numbers from nums in one line. We also square every element in another single line. What makes this special is speed. Python executes list comprehensions using compiled C-level loops, making them significantly faster than writing the equivalent for loop manually in Python. Moving to question 15, explain exception handling. When your program encounters an unexpected situation, like dividing by 0 or opening a file that does not exist, Python raises an exception. If you do not catch it, your entire program crashes. Exception handling lets you respond gracefully. We use 4 keywords. The try block contains code that might fail. The except block catches specific error types and defines what to do when they occur. The else block runs only if no error occurred in try. The finally block always runs, whether an error happened or not. It is perfect for cleanup like closing database connections. Look at the code on screen. We try to divide 10 by 0. Python instantly catches the zero division error and prints a friendly message. The finally block then runs the cleanup no matter what. Question 16. Explain modules and packages. As your Python program grows larger, you need to organize code into separate files. A module is simply a single Python file containing functions, classes, and variables. A package is a directory that groups multiple related modules together. To mark a directory as a package, Python requires a special file called init.py inside it. Look at the code on screen. We import the built-in math module and call it square root function to compute the square root of 16. We also demonstrate importing a specific function from a custom package. This organizational structure keeps large professional codebases clean, maintainable, and easy for team members to navigate. Question 17. What are decorators? This is a powerful and elegant Python feature. A decorator is a function that wraps another function to add extra behavior, without modifying the original function's code at all. They use the @ symbol syntax placed directly above the function definition. Look at the code on screen step by step. We define a function called logger. It takes another function, func, as an argument. Inside, we create a wrapper function. The wrapper first prints a starting message, then calls the original function. We then apply the @logger decorator to our run function. Now every time run is called, the decorator automatically injects the starting message first. Decorators are widely used for logging, user authentication, performance timing, and access control. Question 18. What are generators and the yield keyword? Generators are special functions that produce values one at a time, on demand, instead of computing the entire sequence up front. This is called lazy evaluation. Instead of using return, generator functions use the yield keyword. When the function hits a yield statement, it pauses execution, hands back the current value, and remembers exactly where it stopped. On the very next call, it resumes from that exact point. Look at the code on screen. We define first_n which yields numbers from 1 up to n, calling first_n with 1 million does not generate all 1 million values immediately. It produces one value at a time as you request each one. This saves enormous amounts of system memory when processing massive datasets or data streams. Question 19. Difference between shallow copy and deep copy. This is a subtle but very important distinction that trips up many developers. When you copy a nested data structure, like a list that contains another list, a shallow copy duplicates only the outer container. The inner nested objects are still shared between the original and the copy. So if you modify a nested list inside the shallow copy, the original also changes. This is a very common source of bugs. A deep copy, on the other hand, recursively duplicates every single object at every nested level. The result is completely independent of the original. Modifying it never affects the original in any way. Look at the table on screen. Use copy.copy for shallow and copy.deepCopy for a full deep clone. And for our final question, question 20, when do we use built-in data structures? Choosing the right data structure makes a dramatic difference in performance. If you need ordered items with positional index access, use a list. Lists give you O of n search time. If you need constant, fixed records like database row results, use a tuple. It is lighter and faster than a list. If you need lightning-fast membership checks or want to remove duplicates, use a set. Sets give you average O of 1 lookup time. If you need to map unique labels to values for instant retrieval, use a dictionary. Dictionaries also provide average O of 1 lookup speed. Always match your data structure to your access pattern. This is what experienced engineers do to write efficient, scalable Python programs. Thank you for watching. Subscribe to SHR Trinity for more videos, training programs, live classes, and career guidance. Like and share if this video helped you. Stay tuned for part 3, OOP and problem solving. If you are interested in attending our live training sessions or have any inquiries, all our contact details are displayed right here on screen and are also available in the video description below. Feel free to reach out to us. We would love to have you as part of the SHR Trinity learning community.